Yeah, let me share my just share my screen and make sure that you guys can see the screen.
Yeah,
Awesome. Can you guys see the presentation screen right now?
yeah, we can. You're good to go.
Awesome. Yep. So just before I get started, where are people joining in from? Are they mainly from Barrier University or from the campus, or are people sitting in a room watching this?
Mainly
I
there are
guess.
people from the university and outside as well, but it
Oh,
depends on the timing of the university. There might be some people in the university that are attending right now. They might be at
mhm.
home. They might be at work. So it depends.
Awesome.
Yeah.
Awesome. That's really great to hear. And I really love the initiative. My time back in Pakistan, we didn't have initiatives like this to, teach people the cutting edge technology or public cloud. So it's awesome effort. I know I've been talking to Farhan, uh, but I know all of you are involved in this. So that's really good to hear and, see all this traction. So I'll slowly get started. Uh, Hello everybody. Assalamu alaikum. My name is Moosa Khalid, and I am a senior site reliability engineer at a company called Workday, where I help architect and optimize the deployment of our application to the public cloud and try to make sure that it can be deployed in the least amount of time possible, which is an art of just learning how to deploy on the cloud. But today I won't be talking to you about the intricacies of complex deployments on the cloud because I want to show you the benefits of the cloud, specifically the public cloud, and careers in the public cloud. So my presentation will be a bit lighthearted. I'll be talking about my experience. I'll be talking about what I've seen in the industry, and I'll try to motivate and impart the same passion that I have for public cloud to everybody here. I am bilingual. I am from Pakistan. A little bit of history about me before I talk to you about my technical experience. I speak Urdu. I have lived in Lahore for the past 15, 16 years before I moved to the States. I'm based out of Boston. So it's around 8 in the morning here. And I live with my wife and my 3-year-old son here in Boston, which, the son keeps me really pretty busy. And that's how my work day goes. So with that, uh, just wanted to say that you can reach out to me on platforms such as Twitter, LinkedIn, GitHub, or Medium. I'm most active on LinkedIn, and I occasionally write a blog or two technical blogs on the Medium website that I have. So you can always reach out to me and connect with me, and see some of the work that I've done. So let's talk about the agenda. So the agenda of this is going to be pretty clear. I'll try to talk a little bit about myself as it pertains to the session that we're going through today, my experience and how I came about the public cloud. We'll talk about the public cloud then. I'll try to keep it brief because we all, in some way, shape, or form, understand what the public cloud is, but we do have some sort of insecurity about all these people doing the public cloud certifications and having tons of experience and just like telling you all these mega stories about how they deployed 50,000 applications across the globe with just one click. It's all pretty cool, but everybody has to start somewhere, and that's what I'm here to do for you. I want to make sure that you guys don't overthink about using the public cloud or technologies such as AWS. My specific experience and passion is for the Amazon Web Services public cloud. But if you get started with one cloud technology, you are pretty much good with all of them because the concept and the paradigm is the same, that you are accessing services over the internet. We'll then talk a little bit about cloud careers, about what sort of work you can end up being in, and what that entails. And finally, to keep things interesting, we'll be doing a quick little demo of deploying a virtual machine in the AWS public cloud, where I'll actually hop onto my browser and show you how a beginner like yourself or like myself when I was using AWS would log onto the browser and start using or spinning up AWS resources, so that you can just connect or map how easy it is to get started with the public cloud. So with that, let's start off with the section where I tell you about myself and why you should be looking at the public cloud if you already haven't. So I graduated from the FAST University Lahore. FAST is an acronym. Some of you may or may not be aware of it. Its actual name, it's Foundation for Advancement of Science and Technology, which is what I found out about in the second year of the university but they popularly call it fast. I majored in telecommunications, but the weird thing is that none of my education in university prepared me for a life in the cloud industry. I did not have one module about cloud computing, and I'm pretty sure there's a couple of modules that your university may offer that bring you up to speed about cloud computing. And that's the beauty of how time changes. But whereas in my case, I was working on how to keep telecom systems up and whatnot. And this is nothing against university education. It's amazing. It hones you. It teaches you programming and whatnot. But when I came to the States, and right after my education, I got jobs at good telecommunication companies and vendors. But the disconnect between the technologies that were being used in Pakistan, which were legacy and on premises within the company's own data centers, and what people use here in the States, the public cloud, was a huge gap for me to cover. And that was a bit shocking at start. But the best part is it's really, really easy to get started with the public cloud. So the reason that I'm passionate about the public cloud is because I had to work inside data centers physically. Like there were times that I had to like go drive to a data center of one of Pakistan's top telecommunication company because a server failed and the hard drives got fried. So I had to run with a backup hard drive, get access to get into the data center and push the hard drive inside the physical server, wait for the hard drive to rebuild the data, and make sure that the servers was up and running. Now, nowadays in the public cloud, you would never be doing the same thing. Traveling to a place or securing a server would never be a thing. So I'll show you an interesting picture of my time in the data center. You'll be able to see this picture to the right side of your screen with my legs up on a chair inside a data center. Now, this was a late day. I remember this was past 6, 7 p.m. in Lahore, where I had to go into a data center, and a server was either being set up or something had happened to it, and I had to like rebuild it, start the initialization scripts, install the necessary binaries, and just wait for it to come up. And that's how you had to do it, which is what drove me to have more passion for the public cloud because it's exactly the opposite of what I did in the data centers. Uh, I'll talk about the public cloud in a second, but so carrying on from my story here, that I got introduced to the public cloud in 2017. So that's when I moved to the States. This is about what, 4 years ago. So it's astounding that today I'm working very deep into this field, given that I already only got introduced to this about 4 years ago, and which is also when I got my first ever certification of any kind. So this is the only year, the first year that I got my certification in AWS Solutions Architect Associate. And not long after, I was offered a job here in the States. And although the interesting part is that the job that I got here wasn't directly related to working with the public cloud, but I still kept learning about the public cloud and pushing my colleagues and my boss to adopt the public cloud, which is what got me promoted and into the other roles which involve the public cloud. So that's the passion that I have for AWS specifically and the public cloud. It makes everything easy. You don't have to manage stuff. You don't have to install servers or even take care of renting out buildings. Uh, and now, after these roles, I got hired by a company called Guru, or also known as Linux Academy in the past. And here I was in charge of teaching people how to work with the public cloud, and I created courses on the public cloud. And I'll be honest about teaching and mentoring people, as many of you might have done so, that teaching and mentoring is a two-way street. You learn a lot more from the people than they learn from you. It's because they come from all walks of life and they have the most interesting questions about how to get started. Those innocent, complex questions are what get mentors, on the feet, because you're never prepared for all the situations that your mentees are going to be in. So that's how I got introduced, and I've ever since tried to propagate the knowledge and spread the knowledge. And I'm really, really fortunate that I'm doing this in our own country, Pakistan, today. So I'll show you an interesting picture of a conference that I attended yearly before COVID hit. This is a conference which is held in person in Las Vegas, USA. And this picture is from the 2019 AWS reInvent, where I got into a fight with the AWS Ninja about which was the best service in the AWS public cloud. Suffice to say, there was an interesting encounter. I won't tell you the results about who won, but it was an interesting day overall. So that's how I keep things interesting. I try to participate in events. So this was about me. And just a little fact that as I was, as I moved to the States, it took me about 6 months where I was jobless to find my first job. And I know although I was coming from and already coming from having a job in Pakistan, but it's still a lesson to be learned in humility that, you should always be learning and growing, whether you're a student or a professional who is already in the field. So just remember that you're not alone in the struggle to find passion for a career. Some people on this call may not have a passion to work, and they just want to find a job because they're out of university, and they may find their passion once they get into the job. Some people already have a passion and cannot find or make a headway into finding a job. But just know that everything is, it's a game of time and experience and perseverance. So you gotta keep doing what you're doing. So with that, let's talk about the public cloud. And I'll keep it very simple. Uh, to be honest, and most of you may or may not know this, but there's no cloud. It's just someone else's computer. And why do I say that? Because if you think about it, you're just using the internet to go over, countries or different sections of the world to access someone else's computer. So when you're accessing services like Amazon Web Services, which is a public cloud computing platform, what you're doing is that you are using your own internet or the internet resources that you have to access a virtual machine which is physically hosted inside an Amazon Web Services data center. Now, the beauty of that is that Amazon takes care of maintaining the security of the building, the physical security of the server, the upkeep of the hardware, and everything else, and the electricity and the backup. So you don't have to do it. But it doesn't mean that it's like an ever-present and indestructible machine. These machines will still go down, but Amazon will make sure that you don't get to feel the brunt of that machine going down. And when I talk about, it's someone else's computer, it's true because you're paying that person for using the resources. So when you're using resources provided to you by Amazon or Google Cloud or Azure public cloud, you're basically paying them for the fraction of the time that you've used the resources, such as a CPU or processor or any of the other services provided in the cloud. So it's just remember that it's nothing too complex. Just like you access your university's mainframe system to get your results, you're basically interacting with a server which is hosted somewhere in your university. It's the same thing with the public cloud. You're basically accessing services over the internet and using it to do your work, which may be deploying an application or serving a web app or mobile app. So this is how I would simplify things. Another example of this is that if one of you got up and wanted to uh, you know, create a service just like Daraz.pk or something. And this example does not, actually, Daraz.pk is just an example. I don't know how they run their infrastructure. But if you wanted to run a website which sells shoes and you didn't know about the public cloud, what you would do is that you would go and try to rent a building. Then you would try to buy or rent huge heavy servers to get them transported to the data center that you have rented. Then you would have to set up the backups, the generators, electricity, security. And for a startup, it's going to cost you millions of rupees to get started. So just remember that the startup time of using the public cloud is the thing that attracts a lot of people. And also the fact that it is the hassle of managing the physical hardware is on the public cloud or platform team, not you. So let's talk about a few things which make up the public cloud. And I'm going to be breaking down what you're going to be using in the public cloud. Now, these three things that I'll talk about in a second, compute, networking, and storage, they're basically not an exhaustive list of things that you'll be using in the cloud. There's a lot of things that you will be using, but these are the main things, the basic main things that you'll be using in some way, shape, or form. So the first thing is compute. You're obviously going to require processing and processors and memory and RAM. The second thing is networking. And in most cases, if some of you have worked in the networking background, this is nowadays software defined. So this is managed. The physical aspect of the networking part is managed by your cloud provider, but it is all software defined. And all you have to do as a user is to deploy the rules that you want the networking to deploy. For example, you don't have to worry about setting up a firewall physically or attaching ports to it. You are just going to be caring about what rules you want to apply to the firewall so that for example, you want to allow port 22 or port 80 to be open to allow web traffic. So all you care about is deploying the rules and not the physical hardware, which makes life very easy. And you do this all programmatically. You use API calls, software programming languages to update these networking rules or any components in the public cloud. And finally, the third paradigm is the storage. So this is a networked array of disks which can be connected to your compute, the processor memory, the system which the box which carries your processor memory. So the compute in AWS, and I'll jump in between talking about AWS and the general public cloud. But if I am being specific, always assume that it is the AWS public cloud. So in the AWS public cloud, the compute box, the physical box which runs your processor memory, has its own local disk as well. But that disk is ephemeral. Ephemeral means that it is temporary. So when you terminate the instance or restart it, the disk is blown away. So any data on that partition is done away with. So for that reason, to keep the storage or persist your data, you use storage within the public cloud. In AWS, that storage is called EBS. Now you'll notice me call out terms like EC2 or EBS. Don't be scared. These are AWS's way of differentiating their offering of compute and storage on the public cloud. For your sake, it's just that. It's just compute and storage. So AWS calls the compute service, the service which provides you boxes of processor and memory, EC2 or Elastic Compute Cloud. And they call this storage service the service which allows you to persist data on disks, even if you shut down your processor, your EC2, is called EBS, which stands for Elastic Block Storage. So why did I talk about these three things? The reason that I talk about these three things is because I wanted to sum them up into one word, which is known as infrastructure. So you'll hear this a lot. Anywhere you go, job descriptions and meetings in public cloud domain, and even not public cloud domain, you'll notice people talking about infrastructure, infrastructure this, deploy the infrastructure, take care of the infrastructure, optimize the infrastructure. All the infrastructure are these three things: compute, storage, and networking. And we'll be talking about this because a lot of the careers that you're going to come across in AWS are going to be all about infrastructure in AWS. So then let's talk about the cloud careers. So again, Farhan, I know that we've got audience who are joining from various places, but if you have any questions, I'll be happy to stop in the middle of this presentation because I want to keep this very interactive. So if किसी ने सवाल पूछना है, more than welcome to type it out here or unmute themselves or raise their hand, or even tell Farhan or the organizers, and I'll be happy to stop and answer questions because I want to keep this productive. I don't want to be rambling on about stuff that people are not interested in. Some of this stuff may be interesting. So feel free to unmute yourself, ask questions, and ask them in Urdu, English, Punjabi, although my Punjabi is a bit of a joke in my friend circle, but I'll still understand it at the least. So carrying on with cloud careers, कि आप किस तरह के careers में जा सकते हो public cloud में. So this list is again not a complete list of the domains that you may end up working in, but this is mostly what you will be working on if you were to join a technical role or some sort of role in the public cloud with the company. The first one is infrastructure deployment. Surprise, surprise. That's the first term that comes up in the cloud careers. And that's the reason that went into a little bit of detail about this in the previous slide, because infrastructure, now you understand, is going to sum up these three things: compute, networking, and storage. And why is it so important to be deploying infrastructure? Because you want to deploy a website, right? For that website, let's take a simple example. You need to be able to spin up a virtual machine or a computer, as you call it. You need to spin up networking rules so that you can allow traffic into your application. And then you'll also need to have a storage layer where you'll need to store the files which are being served on your website, or store the information of end users, or even spin up databases. So all that requires careful planning, how you deploy them, what happens if something goes down, what happens if something is breached, what happens if you need to deploy it to a certain country, and you have to take care of the data laws in that country. So it's all about the deployment of infrastructure and solutions architecture. Solutions architecture is a pretty cool, and it's a cool and common term. Whenever you combine this term, you always want to be in a role where you're architecting solutions. And it's, for the most part, it's a very cool role, and it involves you taking ideas and making sure that you design it in such a way that you can leverage the power of the public cloud. One of the main powers of the public cloud is elasticity. Now, you're going to hear this term a lot. Elasticity means that you can, on a whim, spin up 50 machines if needed, just by a click of a button or an API call to the Amazon Web Services public cloud, or you can scale it down or delete the machines from 50 to 20 when your traffic decreases. Whereas in an actual data center, what would happen is that if you've got 50 servers in your own physical data center, and say, for example, that for some reason your company isn't attracting as much traffic, you would still have the 50 servers running and taking up electricity and whatnot all the time. So you're still going to be having to pay the cost for that. Whereas with the public cloud, you only pay for what you use. So in most cases, you're billed by the minute. So if you're using 50 servers or EC2 machines, as we call them in the AWS cloud, you'll only be paying for those 50 machines when they're running, not when they're stopped. So if you see, for example, in the public cloud deployment that, hey, you know what, my website is not receiving as much traffic, you can simply shut down the servers which are superfluous or extra. फजूल के servers को बंद करें और पैसे बचाएं. So you just basically shut them down, and you're not going to be billed for that. And it's as easy as that. You don't have to care about the security, whatnot. So this is where the infrastructure deployment solutions architecture comes in. You'll need to deploy your applications. Nowadays, what people do is that they deploy in microservices architecture. The best way to describe it is that in the past, people used to deploy monolithic applications. If you haven't heard this term, this basically means that you are basically deploying your application on one single system as a bundled application so that it's not distributable across different systems. It runs on one system, and if that one system faces issues, your whole application goes down or has issues. Now, people are moving toward microservices based architectures, which means that they have a separate tier for all the different layers of their application. When I say tier, it means front end where they serve the actual website, the middleware or the middle end where they are terminating the request coming in from the website, and then the back end, which is the database tier where you query the user information or store user information. So now people deploy applications in these three tiers so that they don't have to worry about one thing failing and being the single point of failure. So that if a database fails, you can simply scale up so that your whole application doesn't fail. And you can troubleshoot it separately as well. Then we'll come up to the cloud computing cost optimization, which is a huge, huge thing nowadays because cloud adoption across the world has picked up very quickly. Now people are on the stage of finding out ways on how they can decrease their cost. So I mentioned public cloud is very easy to get started with, but it's very easy to get carried away with the spend on public cloud as well. Because on a physical data center, you actually physically install machines, and so you can see physically the pain of paying for all those expenses. But in the public cloud, it can give you a false sense of cost because you're basically just clicking around or programming 50 machines, and you can easily make a mistake of deploying 1,000 machines because of a typo, and you'll be billed for those per minute. And for these reasons, companies have dedicated people who look at resources in use in the cloud. They look at what resources are being utilized by looking at the metrics such as CPU, memory, how much of CPU is being used, how much of a memory is being used of a system, and then decide if they need to shut things down to save on the cost. It's a very detailed and precise field as well, and something that companies really look for in the resources that they hire. They want to make sure that the person who they're hiring not only is good with deployment, but is careful about the cost of what services he uses. The other thing is migration. So basically, data centers say cloud migration. So you have your data in your own data center, and it's huge. It's like maybe 1 or 2 terabytes of worth of data, and you want to migrate it into the public cloud. That's what we call migration. There's specialized services that AWS offers, and some people may need to move data back from the public cloud to on-prem data center for their own privacy or policy reasons. So you might end up helping companies with that as well. And not the finally, but not the least in any case, is developing on the public cloud. You may end up leveraging services provided to you by the public cloud, such as artificial intelligence, machine learning, or IoT, to build cutting edge technology applications which can empower your community or help your enterprise into spreading into different domains. So these are the 5 types of careers that you might end up being in. Again, this is not an exhaustive list. but it is the five most popular ones that you're going to be in. Some roles may require you to, delve into a couple of these at the same time, or some roles may even require you to be good at all of these at the same time. It all depends on the size of the company that you're working in and your role. So I know I've talked a lot about these careers now, and if you have any questions about these, please feel free to like ask right here or even after this presentation. Now, I want to talk about tips and tricks for cloud careers, coming from a student background who has just graduated. And these tricks, to be honest, are going to be for any career because they apply generally as well. And this comes from my experience. When I moved to the States, I was a shy person. It was hard for me to interact with people, to go up to people. It was hard to admit that I didn't have a job. You know, I know that there's a lot of students or people who are about to enter university who get asked by their parents or different people like, did you get a job yet? Did you get a job yet? Nokri lagi, kya kar rahe ho aajkal? It's just like a stigma that the society puts on you. Do not be pressurized by that, because the more time it takes, the better that you're going to be in a more specialized field. So take your time and network with people. Go out there, be confident about what you do. So my first tip from my experience was to find good mentors, network and connect with them, and don't be shy. Reach out to people. Even if you're looking for a job at a company, reach out to the recruiters over LinkedIn. Just reach out. Do not think twice about before doing that. I'm not saying like go out and start badgering them about giving you a job or just talking to you or teaching you a specific technology. Put in the effort yourself, read up about it, do the research, but then find a person who can give you who can tell you from their experience and their wisdom what to do and what not to do. Finding a good mentor doesn't mean that you just ask the mentor to do your projects for you or to write programs for you or to talk to other people on your behalf. It just means that they're there to encourage you and motivate you, because sometimes that's all it takes. Sometimes all that's stopping you is from getting that job, from getting that project, from getting that recognition, is just asking the right people. If you don't ask, you're never going to get. uh, and that's nothing bad. You got to ask for things in life sometimes. So reach out, connect with people. I myself love to mentor people whenever I get time. And I've got a lot of people who reach out to me from Pakistan, from other parts of the world, to give them advice about passing certifications and whatnot. The second thing is to do mini projects. A colleague of mine who is now head of learning at Google, his name is Forrest Brazil. You may or may not know him. He's pretty popular in the tech space. He started this resume website building challenge for newbies who were looking to get a career in the cloud, it's a chicken and the egg problem. कि लोग चाहते हैं कि आपके पास experience हो नौकरी से पहले, but how do you get experience without working, right? So it's like a weird circle that doesn't work well. Like, how do you get experience without working, and how do you work without getting experience? So for that, you have to take things into your own control and work on projects, just interesting projects which benefit you, and showcase to the people that you can work with technologies. In this instance, we the company that I worked for at that time, A Cloud Guru and Forest, encouraged people to build their resume website using AWS services and AWS's free tier, where AWS doesn't charge you. They give you a certain amount of time and credits to play around with the services, and they won't charge you for that. So the response to this was astounding. People, newbies and beginners, came up with the most beautiful websites, one-page websites, which hosted their PDFs or whatnot. And that's how some of them even got jobs, because an employer who wanted to see if a person had knowledge about AWS, you could literally tell them that, what, my resume is hosted on AWS. It uses Amazon S3. It uses this service. It uses that service. And this is how it works. And this is a very good example of making headway with being beneficial to both yourself and your career hunt. So do these little projects. And then part of this project was to write blogs about the projects. When a lot of us talk about writing blogs, we Google things and we see that, oh, somebody has already written that blog. किसने already लिखी हुई है, so मुझे जरूरत नहीं है. Never think of that. Never think like that. The reason being that you're writing the blog first and foremost, from my perspective, for yourself, because what goes in your head and versus what you can say out loud about things, there's a huge gap at times. So, for example, if I ask either one of you, to describe to me how to spin up an AWS virtual machine in the public cloud. Some of you might say, log into the console and click on this button. So when I log into the console and the button is a bit more difficult to find, I'll be confused as a user. But the better way to write about it would be that go onto this URL, log in using your credentials, and then on the upper right side of the screen, find this button and click on it. So these skills come into your head once you start writing blogs, because as I said, there's a disconnect with what goes on in your head. It's very easy to think about doing this, but it's not as easy to write it down. And the second thing is, even if somebody has already written an amazing blog post about doing what you're doing, still look to plan on doing it, because people will different people find various ways of connecting and reading about things. And your blog post or what you write may help someone in the out there. Now, I'm not the best writer out there, but I have written a couple of blog posts, and there's a lot of people who reach out to me, thank me for writing the blog post and describing things the way I did. Although there was other people who had done this, and this surprised me because I thought that maybe this may not be something which is popular, but I mostly did it for myself because I wanted to improve my technical skills in writing, if you're in a technical role, or just my skills to elaborate on what I've seen and done. This way, you share, you get more confident with what you're working in, and also you get to connect with like-minded people. And the final advice that I have is to communicate, participate in community events. So just like events आज आप देख रहे हैं, आप लोग event attend कर रहे हैं, do keep doing this because you can connect with like-minded people. And this is how I got started with AWS. I went to these conferences in Boston when I moved here, and I met random people at different big tech companies, and learned from them what they did to get there. Learned from them what to do. Got into contacts with the recruiters and got referrals through them. So just by attending these conferences, you can build good references for future, for even for job hunts. So these are my tips and tricks. And now I know if some of you are bored with all this talk, we'll actually jump onto the AWS console to show you quickly how you would spin up an AWS virtual machine, also known as an EC2 instance, install a quick Apache web server on it, and see if the website that you have spun up is working. So I'll switch on to my browser, and this is exactly what you would end up doing given that you already have an AWS account. So I'm just going into Amazon, aws.amazonaws.com. This is the website for Amazon Web Services Public Cloud. Website has loaded, so I'll go into the top right side, my account, and I'll click on AWS Management Console. This will take me to the login screen. Now I'll put in the details to log into my AWS account. And this is exactly how you'll do this. So it's not magic or something too complex, to be honest. So I'll just put in details for my cloud account in AWS. And it'll ask me for my MFA key, which brings me to the point that it's always best to have two-factor authentication on anything that you have in the cloud. A best practice will save you tons of headache in the future if you ever have your account or password stolen. Sorry, your password stolen. So let me quickly put in the authenticated code in here for my account. And there it is. So I'm logged into the Amazon Web Services cloud. So this is the cloud that everybody talks about. This is literally the Amazon public cloud. This is all that there is to interact with it. Not all there is. You can interact with the public cloud using APIs, but for beginners, this is how you'll interact with the public cloud. So this screen represents what you can do with the public cloud. Before I get started with what I'll be showing you, I'll go to the top right side and show you a quick little power of the public cloud. This drop down, the top right side, it says North Virginia. If you guys can follow this, let me know if this is a bit short, small for you. I can try zooming in. I just want to make sure that you guys can see what I'm doing here. So all these lines or rows that you see here in the drop down are all different regions in AWS. So this is the power that the public cloud offers you. There's like 1, 2, 3, 4, 5, 4 data centers in the US, one in Africa, various in Hong Kong, Mumbai, Osaka, Seoul, Singapore, Sydney, Tokyo, Canada, Europe. There's like London, Milan, Paris, even in Middle East recently in South America. So you sitting in Pakistan can literally spin up an EC2 machine or some resource in any of these countries. So I could physically not be there and spin up resources there. So say for example, I'm trying to sell shoes in Japan and I need my website to be quick in Japan. I would just literally click on Asia Pacific Tokyo. The page loads, and now I'm in Tokyo. I can, whatever I deploy will be deployed in the Tokyo data center of AWS, and boom, there you have it. This is the power of the public cloud. You don't have to worry about transportation, logistics, whatnot. You just have to worry about what you want to deploy, which really cuts down the time. So I'll go back to the region which is closest to me though, US East 1. And basically, I'll be clicking on this EC2, but if you don't see it here in the recently visited services, you can just go up here in the search bar and type EC2. EC2 stands for Elastic Compute Cloud. The 2 is for the 2 C's in this acronym, Elastic Compute Cloud. So I'll click on this and I'll shut this little pop-up down. And in most cases, you're going to be given this EC2 dashboard. So on this dashboard, you can either click on instances, or if you go to the left options pane, you can click on instances as well, which I'll do. And right now we don't have any instances running. So we'll launch one or run one. So I'll click on launch instances. And the first thing that AWS will have you do is decide the operating system that you want to run on an instance, right? You cannot run a computer without an operating system. You need Windows, Linux, or Mac OS. You need something. So in our case, we'll select a popular derivative of Linux that Amazon provides. It is known as Amazon Linux 2. The AMI stands for Amazon Machine Image. It provides you a little description about what this OS has baked into it, and also gives you a specific ID for this image if you want to programmatically access it. So I'll select this image, the Amazon Linux 2 AMI, because I'll be using commands which pertain to the Linux operating system. The next page will have you decide the type or the flavor of the virtual machine that you're spinning up. So Amazon gives them types and family names to make it simpler to select. But basically what you're doing here is selecting the CPU, memory, and networking specs of your virtual machine, just like we talked in infrastructure. So in this scenario, the lower down you go, the resources keep increasing. But also remember that the more beefed up a system is, for example, the more memory, the more CPU or RAM something has, it's going to cost you more money for that. And this is billed per hour and per minute as well. So I'll go with the modest T3 small, which has 2 vCPUs and two gigabytes of memory. It has an EBS only disk. Remember, we talked about EBS being the storage service that Amazon provides, the persistent storage service. EBS stands for Elastic Block Store. It is optimized for EBS because your compute is connected to the EBS via network. AWS will, in some instances, optimize the network connections between your virtual machine and the disks which are connected to your virtual machine through a network. Your machine can, send packets back and forth up to 5 gigabits and supports IPv6. The next page is probably the most intense one with regards to input. There's a lot going on here, but I'll skip some of this because it may be either too complex or irrelevant in the scenario that we're talking about, because I do want to keep things simple. So remember that we talked about how you can literally spin up 50 machines in one go. This is where it happens. You can literally put up 50, and once you're done putting in the details, 50 EC2 virtual machines are going to be spun up in the North Virginia data center. But you will, in some instances, have to talk to AWS about increasing your limits because they don't want you to accidentally spin up 50 or 60 or 100 machines and cost yourself a fortune. So sometimes you may need to reach out to AWS to increase the limit of resources that you can deploy. In my case, I'll just keep it at a 1. The next thing is the most important one here, the networking aspect. So AWS has already provided us, in my scenario, I've already created a chunk of logical network, which I'll be breaking down into smaller chunks or subnetworks. So this network is called a virtual private cloud, VPC. We're not going to be going to the details of networking in AWS, but to deploy an EC2 instance or virtual machine, which needs to have an IP, because you want to connect to it using that IP, you need to deploy it inside a VPC or a network. So this network, as I mentioned, has been split into various subnetworks. In our case, if I click on the subnet drop down, you'll see that it has been divided into six subnetworks. So this VPC had a huge IP range, and we split it into six IP ranges within that larger subnet, within that larger network. The next option asks me if I want to attach a publicly addressable IP address to my machine, which I do, because that will allow me to connect to it over the internet. If I choose not to enable it, I won't be able to connect into or with my machine. We'll skip on this part, placement groups or IAM roles, and we'll go straight down to the behavior. You can define what happens if you shut down the machine from within the machine. So if you go down and if it's a Windows machine, if it was a Windows machine, you would go down and click on shutdown. What would AWS do? Would AWS stop the instance and keep everything intact for you to start at next time? Or would it terminate? To save on cost, most people will click select terminate, but I'll stay with the default of stop. You can either set the machine to be hibernating if you stop it. You can also protect it from deletion in case someone tries to delete it by checking off this box. You can also enhance your monitoring or observability of the usage of how much CPU is being used, memory or storage using enhanced CloudWatch metrics. CloudWatch is a service which monitors and provides you these metrics from the virtual machine that you're working on. We talked about EBS optimize already. Tendency means that your virtual machine may be running on a shared hypervisor. So even though you are abstracted out from other people, but you may still be sharing the resources of the public cloud. Now, this doesn't mean कि आपका data shared है दूसरों के साथ नहीं. At a hypervisor level and at all the different application levels, whatnot, AWS makes sure that you are not sharing anything with the customer. You just are multi-tenanted. You're just sharing their hardware, but not your data or any of your application. But for some people, they may need to use dedicated hardware for maybe GPU acceleration or whatever their application requires from a system, and they may want to use a dedicated hardware on which is not being shared with other AWS customers. But it will cost you extra money. So I'll just stay with the shared tenant. Inference pertains to the deep learning aspect, so we won't be using that. We'll skip on credit specification. And this is the part which is the interesting one here now. When you're working with AWS, you can provide it a quick little script or piece of code to run as your system is coming up, which is what it will do. So without going into the details of the configuration of the script, this allows you to set up the various configurations. We'll just talk about the code itself. I'll be writing a quick bash script to install an Apache web server and configure it to serve a single page website. So I know that my Linux AMI that I'm using has the bash language installed on it. So I'll quickly write this code and let me see if I can zoom in on here. So yep, so I'll just write this quick little snippet of code. Some of you may be familiar with this if you work with Linux OS, some of you may not be. Don't be scared. You can do this with any operating system that you're comfortable with. So if you are comfortable with Windows, just select a Windows OS and just start typing in whatever language Windows supports. So yum install, as evident by the name install, will install the Apache web server package or the software. I'll then tell the Linux system to enable the Apache service in case the system restarts. I don't want the system to the service not to come up. So this enables the service to come up by itself if a system is stopped and restarted. I'll then tell the system to start the Apache web server. HTTPD is the name of the web server. And then finally, I will create a single page. I'm not too good with HTML or CSS, so I'll just type a quick page saying my first web page, and I'll output it to a directory where I know Apache web server looks for serving to your public facing website. That is usually inside the var www html index.html. So I'm outputting creating this page. By this command, it's going to create this file index.html inside this folder. And once the web server is up and running, it's going to serve this website or just a one-line page that I've created. publicly over the email, the public IP of my virtual machine. But we're not done yet. So this is the part where we have configured the internals of the virtual machine. Next, I will select what amount of storage is connected to the system. By default, your AWS virtual machine comes with a root volume, and this is a mandatory thing because your operating system needs to be deployed somewhere, right? For that reason, you are already provided the local root volume, which is attached to your virtual machine. But you can also attach additional volumes. So just like this, you can attach as many. I don't know the exact number of things, but you can easily attach about 10 or 20 EBS or storage disks to your instance. You can select the space here. So I'll just delete these extra ones that I created. By default, the root volume is 8 gigs, and you can also have it encrypted for safety, which I recommend in most cases, which I have done it. You can also get it, deployed without any key. And you can also select the behavior on termination of the virtual machine. So what happens if you delete your EC2 or virtual machine? Do you want your disks to be terminated with it or not? In most cases, you would want to, if you're learning, you would want to get it, have it deleted so that it doesn't cost you. So just remember that, even if you delete your instance, your disks can be left behind. So you have to delete them as well. Next, I will be labeling or tagging our EC2 instance. Just like when you tag your lunch, when you take it to the office with your name so that other people don't mistakenly eat your lunch or tinker or mess with your lunch. It's the same thing with AWS. To keep your instances safe and let other people know what they are built for and who deployed them, you can give them tags. It's a very good practice to do so, and I'll recommend that you do this if you're in the public cloud. So I've given my EC2 instance the name test VM. Next up, I'll be setting up the firewall rules for my EC2 instance. Now, this is the networking part that I mentioned. This is the networking part that AWS simplifies for you. So although in the backend there's a firewall somewhere that I don't have to worry about the hardware of that firewall. All I have to worry about is the rules on that firewall. And those rules are deployed using security groups in AWS. So I'll just name this security group test VM SG, where SG stands for security group. I'll give it the same description. And you'll notice that AWS has already provided me with one rule, which allows anyone on Earth, so 0.0.0.0/0 means that any person who's on the public internet can access my machine using the SSH protocol. Now, I'll only allow it this once because we are in a demo and I just want to showcase something to you. But never, ever, ever do this in production or inside a workplace unless you have consent for doing so, or unless your work requires you to do so, because this is a huge security risk. It opens up a huge attack vector on your systems if you allow anyone to connect to SSH. SSH, for those of you who don't know, is a protocol used for connecting to machines over the internet securely. I'll then add the HTTP port. This will allow anyone on Earth to be able to connect to my system over port 80 on its public IP address. And also note that AWS is warning me about the all allow all rule that I have in my ACL. But we are aware of the risks, and this is just a demo, so I'll move forward. Next up, a quick summary of what you're deploying, so you can quickly go through what you have configured. And once I click on launch, we're still not done because we need a way to connect to our instance, and that is through SSH keys. So you create a key pair via AWS, you get half of the private key of that key pair, and AWS embeds the other part of that key inside the virtual machine that it is spinning up. And then you use the key that you create here and download to connect to that EC2 instance. If you don't create a key pair, you won't be able to connect to an EC2 instance as easily. There's other ways that AWS provides you to connect to EC2, but for beginners, if you're using the public key pair, just don't lose your private key. So I'll click on the drop down, click on create a new key pair. I'll name my key test VM, and I'll click on download key pair. This will download it into my local directory in downloads. Now keep this very secure. Do not give it to anyone, and just keep it safe and secure. So then I'll click on launch instances finally, and this will launch the instance for me. So my instance is now launching, and I can click on the instance ID, which is how AWS uniquely identifies every virtual machine on AWS. And it's being spun up. As you can see, it's initializing and it's in running state, but we'll give it some time. Meanwhile, we'll head over to the CLI and set up the key that we downloaded. So just want to make sure that everybody can see the screen here. If not, I can maximize it to make it better for viewing. But I'll cd into the downloads directory, which is where I have downloaded my key. And I'll do a quick ls on the file that I downloaded, which is called testvm.pem. And for files which are private keys, uh, in Linux or in any other operating system, you need to make sure that they are not readable by the world. And if you're not too much aware of Linux, this here tells me who can read the file. Ideally, you don't want these last two R's here because they mean that the other people, groups within the system, and anonymous people can read this file, and we don't want that. And even if we try to connect to our instance using this file right now with these permissions, we will be denied access. So I'll quickly run a command to change that. Uh, don't need to worry about this command. It's specific to Linux, but we have to do this step to connect to our EC2 instance. So once we're done with this, what will happen is that we have removed read access from anyone else but ourselves because we are the owner of this file. And it's a good practice too because this key contains sensitive data that you don't want everybody to be reading. So now that we have got this, let's go back to our console and let's click on our VM. And for some reason, usually this bar is not hidden, but in our case, it was hidden. So even if it's hidden, just click on this up arrow to expand it. So our machine is still initializing. These are status checks, but it's running. These status checks are by AWS to make sure that the hardware is working. But we'll quickly go down to the details. So I clicked on the virtual machine that we spun up, and we can identify it by the name that we gave to it. Remember the tag that we did? We have the details. We'll go into the public IPv4. This is the address that we asked to be attached to this virtual machine when it was starting up. It also has a DNS name. DNS names take a little bit of time to propagate, so they may take some time to load at times. So I'll prefer using the direct IP address of the machine. So I'll just click on these two square boxes to copy over the IP address. And now we'll connect to the instance. So just remember we had opened public access to our instance using the firewall rules. So I'll use the command ssh-i, which means that I'll be minus I means that I'll be providing it the private key. I'll give it the private key. And there's a user that is pre-configured on all Amazon Linux AMIs, the operating system that we chose. Amazon pre-configures a user called EC2-user. Just like you have an admin user on Windows, you have an EC2-user on Amazon Linux to AMI. So we'll be connecting using that user. And then I'll copy the address, the public address that I got from the AWS console. So I'll hit enter. And since I'm connecting to this instance for the first time, I will add its fingerprint to my known host file. And there I am. So I'm connected to the instance. This is the EC2 instance that we spun up. Now let's quickly issue a few commands to see if our web server that we installed through the script during configuration of the EC2 instance is running or not. So we'll be using the command sudo systemctl status httpd, and we can see that our web server was installed and is running successfully. We'll also quickly output the contents of the file that I created using the echo command in the configuration that you saw earlier. So I'll just do var html index.html, and there it is. This is exactly what I wrote in my script. So it means that our script was run successfully and that our web server is spun up. So what I'll do now is to go back, get the public IP address of my machine, open up a new tab in the browser, and just paste the public IP address here. What do you think is going to happen? It sounds very easy to do, and this is how easy it is. But once I click on enter, this is my web page loaded, and it is publicly accessible. Any one of you can put in this IP address on their browser and get access to this page. So notice how easily I was able to, within what, 5 minutes, deploy something which is publicly accessible. I can easily control who can connect to this machine or who cannot connect to this machine. I can go back to the EC2 instances console and even stop this machine. So say, for example, I'm serving my high flying website, which has a lot of traffic, but at nighttime, nobody uses it, or there's no need to have this web server up, and I don't want to get charged for it. So I'll quickly go back to the console. I'll select my machine and I'll click on stop instance. There you have it. And I'm not getting charged for this anymore. I may still be getting charged for the volume that is attached to this instance because it has persistent data. And you can look at the volumes that are attached to this instance by going into storage, selecting this VM, going into storage, and it's going to show you the volume ID. You can either find it this way, or you can also go onto the left pane, EBS, Elastic Block Store, and click on volumes. And it'll give you all the details of this volume. Now we have chosen for this volume to be deleted when we delete the instance, so that's good. However, in some cases, you may want to keep the volume around and attach it to some other instance if you're migrating from one virtual machine to another. This volume is in use now. So I've stopped my instance, right? My website should be running. So let's refresh this page and notice that it is stuck on loading, which means that my website is brought down because I stopped the instance, right? Now notice what happens. So it's timed out, and rightly so too, because I've shut down the virtual machine on which this website was running. So I'll go back to my instance and I'll click on instances to go back there. And it's in stopped state. And now that it's stopped, it doesn't have a public IP address, and therefore it cannot be connected to. But it's still within the same VPC and the same subnet that we selected. So let's start it back again and see what happens now. So I click on start instance. And as it starts up, I'll select it. And you'll notice that it comes back with a different public IP address. So I'll give it some time to start up. And you'll notice that the DNS name has also changed because the DNS name takes into account the public IP address. So once it's done starting, I'll give it a few more seconds, I guess. It should start working. You'll notice that our previous public IP address is not working. And we'll just wait for it to time out. And we'll open up a new browser tab and put in the new IP address and see if it works. Oh, and there it is. It's pretty quick, actually. I just started it a few moments ago, and the server was up within seconds. The reason that it spun up so quickly was because all it had to do was to start the instance, which is pretty quick, assign it a public IP address, and the disk was already there. And the reason that we are seeing the same data is because the data was persisted on a block device, the EBS volume that we just saw. And this is how you would be deploying on and using EC2 virtual machines. Other things that you can do with this is to now let's see what else we can do with this. We can change the script that is being deployed on this instance. We can change the termination behavior. So I'll go here and quickly enable this. So say, for example, you are in love with an EC2 instance and you don't want it to be destroyed. You can have the termination protection enabled on it. So now if I, as a malicious actor, try to delete this instance myself, even if I try to delete myself, I'll get an error message saying that, hey, you had termination enabled on this instance. And I get an error saying that failed to terminate instance. The instance may not be terminated because you have enabled termination protection on it. So you can save your instances from being terminated through this option. I'll disable this for right now. So now that I'm done with this, it's best practice to delete instances or resources that you're not using. So I'll select my virtual machine and I will delete it. I can also reboot it. So in my case, I just want to delete it because I don't want to get charged for something that I won't be using. So I click on delete and then terminate. And this time it will let me terminate that instance. It takes a little bit of time, but if I go down here, the volume will not be deleted yet. It'll be deleted as soon as that EC2 instance is deleted. But that's only because I chose in the configuration of the virtual machine to delete anything that is attached to the virtual machine. So This was a quick little primer on using the AWS public cloud. This is your, if you've never worked with this is how easy it is. Most people, experts, will connect to and deploy resources using APIs or programming. But in this case, I just want to showcase how you could just click around to create a virtual machine in another part of the world. And our instance is terminated. So if I go down to volumes, our volume is gone as well. And we're done. We're not being charged anymore. And also our website would be down. So when I talk about jobs in AWS, you may have a client who wants to host websites on EC2, and they'll ask you for ways to keep this website highly available by making sure that it's load balanced and it doesn't go down if one EC2 instance goes down. So these are the kind of jobs that you'll be working in. So with this, our demo ends, and I'd like to thank you all for sticking around and listening to me. I know it takes a lot of patience to listen to someone ramble about things that you may not have too much experience with. I'll be happy to take any questions that you guys have. I'll be happy to connect with you all on LinkedIn. I'm most active on LinkedIn, but I'm also available on Twitter and Medium. I've everything that I have, my showcase of work is on LinkedIn. You can connect with me via this URL. And also, if you have any questions, submit them to Farhan. Uh, Farhan, if you're on the call, thank you.
Yeah, Musa, thank you so much for coming out at 8 a.m. right here in Boston. And
Yeah,
before you
it's
go,
fun.
yeah,
Mhm.
I still need that answer. Who won between you and the ninja in AWS Ninja's competition?
So it turns out that she had a something which was blowing air into her, into her costume.
Yeah.
And when I kicked it, all the air went out actually accidentally. So right after this picture, she was like deflated.
Oh,
And
so
I would
basically
say
you won.
I would say I won. I'll be attending the conference again this year,
Uh huh.
and I hope I bump into the AWS Ninja. They do like different costumes every single year.
Right.
And the interesting part is that the conference has a lot of like fun aspects. They've got like costume people walking around, and I do lose to a lot of people like like wearing costumes. And talking about costumes, I don't know if you guys follow the events happening here, but it's like Halloween
Yeah, it
today. So
is. Yeah.
I'll be dressing up as a doctor, yeah, because
Uh
sometimes
huh.
being an engineer is tough.
Right.
So yeah, so yeah, and
Mm.
just अच्छा initiative है. I'll just say कि keep continuing on with this. Future में भी अगर कोई event होता है, I'll be
Right.
happy to talk
Yeah,
and present something
we'll make sure to
specific.
follow up with you, obviously.
Yeah, sure. Yeah. And yeah, I think this is it. One last thing is that this template I put up quickly because I'm a lazy person. I've got a 3-year-old son जिसको मैं पीछे भागते भागते मैं भूल जाता हूँ चीजें. So this presentation template was from Slides Carnival, and any pictures on this presentation were from Unsplash. So if you guys are looking to get some amazing templates, they are from Slides Carnival. But yeah, for who's this I'm talking with right now? Is this Farhan
No, this is
or
Usman. I am one of the
Usman?
organizers. Yeah.
Awesome, Usman. Thank you, yaar.
Yeah,
Thank
thank
you
you
so
so
much.
much, everyone. This was Musa Khalid with AWS, and we hope you guys enjoyed the session. And thank you so much, Musa Khalid, once again. It's an honor to have you coming out at 8
Thanks,
a.m.
buddy.
from Boston.
Thanks,
All right.
buddy. Yeah, it's always
Bye.
an honor. Thank you.
Bye,
Bye.
guys. See you. Bye.